Here we have a segment, and our goal is to measure it. Sometimes in life, we have tools that we can use to directly measure the object. Other times, we need to use math. So one way we can do that is we can place the object onto a number line, like this, and then what we can do is count the distance from one end to the other. And for example, 1, 2, 3, 4, 5, 6. So this has a length of 6 units. Sometimes we don't have a diagram where we can directly count the distance, and so in that case, we can use the endpoints. One end is at 5, one end is at 1, and we can then subtract them to find that distance. So here's the 1, subtract away the -5. 1 plus 5 is 6. And so we have two different strategies that result in the same length. Now, what makes measuring the distance even more challenging is if the object is not nicely on the grid. For example, this length from point N to point P, we can't directly count along this segment because there's no clear grid markings that we can count. So instead, we need to come up with a different strategy. Sometimes students will come up with the solution of, well, why don't we just count along the grid to the right and then count up? However, this is too long of a distance. We want the distance going directly from N to point P. So here's the solution. The solution is to use something called the distance formula. This is used to determine the distance when you know the location of the two endpoints. Letter D does stand for distance, right here. And then after the equal sign is the actual formula. In this formula, you'll see that there are 4 colored measurements. Those are the places that we are going to be filling in numbers when actually completing the calculation. And everything that is written in black will stay the same, usually stay the same in every problem. So we need to know what the endpoints are. This right here is representing the x-coordinate and the y-coordinate of an endpoint. And we do have a second endpoint, and so to keep them straight, we use these little labels. This little 1, this little 1, this little 2, and this little 2 are called subscripts. The subscripts are only labels, so that way we can tell the 2 points apart. These little 1s and 2s are not actually used in the calculation. And so in the formula, these 2s and 1s, again, they're not going to be used in the calculation. They're just so that way we can figure out which point that it came from. You get to decide which point in the diagram is the first endpoint and which one is the second endpoint. If you switch the 2 points, you will still end up with the same distance and the same result at the end of the problem. Now, I do also want to mention that sometimes the math problems will literally say calculate the distance, and so you can look for the word distance in the question. Other times it'll use a different word. It'll use the word length. So if you see a question asking you calculate the length of the segment, this is still the appropriate formula to use. So comparing this endpoint 1 and endpoint 2 to an actual problem, right? If this is the diagram that you're presented with, then you will have to make the decision which of these points is your first and which one is your second. I'm going to choose to make letter A the first point and letter B the second point. And in these coordinates here, if you're like, which one is the x-coordinate, which one's the y-coordinate, they do appear in alphabetical order. So if you can remember x, y, and z, then that helps you remember that the first number is x and the second number is your y-coordinate. So I'm going to label the x-coordinates, and I'm also going to label at the same time the subscripts. This is my first point and this is my second point. And then for the y-coordinate, which happens second, again, this is my first point. And then when I label the other y-coordinate, this is my second point. And then we can fill in the 4 numbers appropriately into our distance formula. Sometimes you'll see diagrams of segments like this floating in white space, but the segments can also appear on graph paper, in which case we would have to measure where those points are on our own. Most students will label the actual diagram. For example, when we locate point A, notice that we can count starting from the origin. So it is located to -1 and then up 3. And so we can write that down as -1, 3. And if you're not sure which number goes first, you're like, I can count the -1, I can count the 3. How do you remember which order to write them in? The memory trick that I like to use is that you need to walk to the elevator before you can use the elevator. So let's practice that for point B. If I want to go from the origin to point B, I have to walk to an elevator, and then I can use the elevator to go down. So when counting, we walk 2 units, and then we use the elevator to go down 1, 2, 3, 4 stories. So that's a 2, and then minus 4, and we can use those when writing the coordinates. We walked 2, and then we went down 4 stories. Let's try an actual example. The first example that we're going to use is right here. When we look at the question, it says determine the length of segment AB. So that's what's in the diagram, the segment from point A to point B. And because I noticed that keyword length, that's the hint that tells me that we need to use the distance formula. Here is that distance formula. I recommend copying it directly from your notes. And now we can fill in the 4 measurements into this formula where the colored letters are. To make that easy on us, let's label point A and point B as our first and second point. I'm going to make letter A our first point again, and I'm going to make letter B our second point. And now we can directly fill in these 4 numbers into the appropriate place. All of the text that's in black does stay the same, so I'm going to start with that, and then that way it makes it easy for me to fill in the numbers. So let's start with the first one. We have x sub 2. X sub 2 is a 2. And then x sub 1 is a negative 1. So yes, we do have a double negative here that we'll have to deal with. And then when we look at the y coordinates, we have y sub 2, which is negative 4, and we have y sub 1, which is 3. From here to the end of the problem, we need to simplify and reduce until we have a single number that represents our length. So let's use order of operations until we get to our results. We're going to start inside the parentheses. So in the first parentheses, this 2 double negative 1, double negative is the same as a positive, so this really means 2 plus 1. 2 plus 1 is 3. And then in the other parentheses, we have negative 4 minus 3, which is negative 7. And now we can use the exponents on those parentheses to simplify further. 3 squared is 9. Squared means to multiply the number by itself. So 3 squared is the same thing as saying 3 times 3. And then over here, negative 7 squared means negative 7 times negative 7. A negative times a negative is a positive, and 7 times 7 is 49. Notice that at this step, you will always end up with positive numbers, because if it was positive to begin with, it'll stay positive. And when you're squaring a negative number, negative times a negative is always positive. So at this step, you should always have positive numbers. Last thing to combine is the 9 and the 49, which gives us 58. In some situations, this will be how you leave your answer. We call this right here exact form because the answer is that the distance or the length between these 2 points is exactly the square root of 58. However, sometimes we want decimal form, which is usually a little bit easier for us to understand. And so I am going to pull a calculator onto the screen so we can find an approximation of the square root of 58. So here is my calculator. The square root button can be found near the 7 key. It's in blue. And so I will press the blue second button and then that button next to the 7, and you'll see the square root symbol. And now I can fill in the 58, hit enter, and it gives me a decimal approximation of 7 point, I'm around to the hundredth, so 7.62. 7.62. Now that right there is the length of the segment. And so if I was trying to add this to the picture, what this 7.62 represents is it represents how far it is all the way from point A to point B. That distance right there is the 7.62. I do want to also mention that if your goal is decimal form, so I'm going to actually label that right here as well. This is decimal form. then you can jump straight from the original formula all the way down to decimal form by typing in all of the symbols into your calculator at once. So let's try that out. We're going to just type in this first line here. So we're still using the second button and the square root button, and then we need to fill in everything as it appears. So we are still going to use the parentheses, and we're going to use all the appropriate symbols. So I have a 2 and then a minus. In the formula, the black minus signs are the minus signs. So use the minus button above the enter button. And then in the -1 and -4, they are negative numbers. So we need to use the negative button, which is different from the minus button. The negative button can be found down here at the very bottom of the calculator. So I'm going to use negative. Notice how they do look different on the calculator screen so you can tell them apart. We have a -1 and then parentheses. The squared symbol is the same button as the square root symbol, just without pressing the second button. So it's that little squared. Now we can add to the other parentheses, so negative button again, and it looks like I missed a parenthesis. Let me try again. All right, and then -3, and then we have the other squared. Double check that you've got all the correct symbols, hit enter, and we have the exact same result. So your choice depending on what your goal is on how you get to your answer. Let's take a look at another example. In this example, it's asking us to determine the possible values for x if the length of CD is 20 units. So I notice we have segment CD, and it gives us the location of point C. It tells us that the length, so that's already like, the answer to the formula, right? It says the length, the distance, is 20. So I can directly add that to my diagram so we don't forget. This distance here is a total of 20 units. And then it's asking us to determine the value for x. Value means number, so we are trying to find the number for letter x. Okay, let's do it. Now, because this is a length problem, that means that the distance formula will work here. So I'm going to drag that onto the screen. Again, copying the formula down first and then filling it in is the best strategy here. We now need to figure out which of these points is point 1 and point 2. I'm going to do it in alphabetical order again, so that means that point C is our first point, and then point D will be our second point. Let's label the y coordinates. Same thing, we've got the first point and the second point. And now we can fill these four into our formula. So let's do that right now. We've got our x coordinates and then our y coordinates. So x sub 2 is just x. Okay, so that's easy. X sub 1 is -5, so we do have a double negative again. Y sub 2 is 10, and then y sub 1 is -6. We have another double negative. All right, now I purposefully did not bring down letter D, and that's because we actually know the value of D. D is the distance, or in other words, the length, and we know that the length is 20. So we can fill that in right away. And this makes the equation solvable because now there's only one variable, and so we can get this variable by itself to get an answer. If we are trying to solve an equation for x, the strategy is to use opposites over and over and over again until we have isolated x. There are a lot of things connected to x right now, and so we will be using a lot of opposites. I'm going to simplify a little bit, and then we'll start using the opposites for all of the operations that are furthest from x, and then we'll work our way towards x till we get to the end. So I noticed that the easiest thing to simplify first is the double negatives. So let's do that. We'll write the double negative as a positive. And then over here, these are numbers. We can even add these together right away. We have 10 plus 6, which is 16. And I'm going to continue simplifying. We can do 16 squared as well. So I'm just bringing down all of the measurements that are still the same. And 16 squared is 16 times 16, which is 256. Almost forgot a squared there. All right, so now's the time to start using opposites. So when we're looking at our variable x, the furthest opposite away from x, mathematically, is this square root symbol. So let's use the opposite of a square root to make it disappear. You might be like, well, what is the opposite of a square root? Well, that's a great question. We know that we have a lot of opposites already memorized. For example, positive and negative, or multiplication and division. Well, it turns out that square roots have an opposite as well. A squared is the opposite of a square root. So if we want this square root to disappear, we need to put a squared on both sides. Now I'm doing this on both sides because we do need to keep the equation balanced. So here's my equal sign in the middle, and I'm putting the squared on both sides. Just like usual, the opposites cancel, which means there's no actual work to do there. And let's bring down everything else that's remaining. So 20 squared is the same thing as 20 times 20, which is 400. And then on the right-hand side of the equal sign, the square root symbol is no longer there because it canceled out. And so what we have left is everything that was inside of the square root. We are one step closer to solving for x. Now the next value that is furthest away from x is the 256. So I'm going to now use the opposite of 256, which is subtracting by 256. And we need to do this on both sides of the equation like usual. And so our result is we have 144 on the left after subtracting. And then on the right-hand side, we still have the x plus 5 squared. The opposites have canceled out. So next, the furthest thing away from x is the squared, and the opposite of squared is square root. So we need to square root both sides. We're going to square root the right, and we're going to square root the left. The squared and square roots are opposites, so they cancel out, which leaves just the x plus 5 remaining. And on the other side, the square root of 144. And we actually get two answers because this is asking us what two numbers can multiply to 144. And one way to multiply to 144 is 12 times 12. But the other way is negative 12 times negative 12 also equals 144. So there's actually two possible answers that we could have for the square root of 144. I'm going to write that out over here just in case for clarity. So 12 times 12 equals 144, and negative 12 times negative 12 also equals positive 144. So that's why we don't know which one is actually the true number. So we're going to have to split this problem into two parts, solving it once with positive 12 and then solving it again with negative 12 just to see what happens. So I'm going to split my workspace into two so I can do each way. So let's start with the positive version. And then I'll write the negative version over here just so we don't forget. So here's the negative 12. So I'm just copying this line of work twice, one with the positive 12, one with the negative 12. And now there's only one step left. We can handle this. Let's subtract 5 from both sides. And now x is finally isolated. We have 7 for x. Okay, and then on the other side, over here, we also have one step left. Subtract 5, and x is by itself again with a negative 17 this time. So we have two answers for x, 7 and negative 17. And you might be like, wow, how is that possible? How did we get two answers? Like, which one is the actual location of point D? Is point D at 7, 10, or is it at negative 17, 10? And it turns out it could actually be either one. There are two possible right answers for where point D is located. So this is the end of the problem right here. These are the two places that the x-coordinate could be. Now, if you're like, well, why is there two possible? Well, here's a diagram of the actual points. Here's point C, which we know is located at negative 5, negative 6. So that's fixed in place. But point D could be anywhere, right? It could be anywhere in this graph paper. We don't know where the x-coordinate is. We do know that the y-coordinate is 10, so this point does need to be somewhere at 10, which does limit where this point can really be located. But for a moment, imagine that this point, point C, is fixed in place. We can't move it. And imagine that point D, though, can be moved around. We do know that the length of this segment has to be 20 because it told us that the segment was 20. And so if we were forced to keep this segment 20 units away from C, imagine if we swung it around. Point C stays the same, but this segment can move around. We would essentially be sweeping this segment in a circle, such as something like this, where as we spun the segment around, point D would trace out this circle, which means that point D has to be somewhere on this circle. And one place that it can be is where it's graphed currently. It can be graphed at 7, 10, which is one of the answers that we got. We got that it could be at 7. Now, if we continue swinging this segment around, the other place that it could be is right here, because we know that the point has to be 10 high. And so if we swing it around in a circle, it turns out the segment could be located over here, which is at about, yeah, I'd say that this is about -17 to the left and 10 high, which is why we got a second answer that x could be at -17. So in conclusion, you now know how to solve for the length or the distance of a segment using the distance formula.